Right, so I'll talk about some of the things that I didn't show you. When I initially got this in here, the first thing you might want to do is scope the various pins. So I scoped the H-Sync and V-Sync out down here, and I could see that I was getting twice the resolution. It's like 31.5 kilohertz on one pin and 50 hertz on the other. And then I started to scope the colour bits because I still wasn't getting any video, so I scoped the RGB inputs, wherever those are, somewhere up here I think, and then the various outputs. You know, you've got the doubled line RAM, you've got the combined line RAM, whatever it is, the one where it uses to combine it, and the frame RAM. And I could see activity all over the place, but well, it's just I can't get proper video. So you saw me test it in the other room there on the other display, and I just forced it into the lower, you know, the standard H-Sync and V-Sync, not, you know, scan doubled, and passed the video straight from the input into the TPLD here, straight to the output side, all 12 bits, and we got a display. From there, I've done a number of modifications to try and work out, you know, where the issues are. I've got problems with the clocking on this RAM, the reset signals, the read and write enables. You know, Matse did things in a bit of a different way, and it's causing some issues. Certainly on the read and writes of the frame RAM, uses a 7.4 series somewhere down there, and there's a clock goes into that as well, which he doesn't, you know, he doesn't have a flip-flop, he doesn't need a clock for the flip-flop. I might need to take this into the room now and scope that pin to work out what clock goes in. On the diagram, the 3000 schematics, it shows 14M, N_14M. What's the N? Does that mean it's inverted? It could be. It could be an inversion of the 14 megahertz clock. Nevertheless, because I'm struggling, certainly on the display I'm using here, to get it to be stable, it's like I can run the code, I can compile it and deploy to here, and then get, you know, varying issues depending on what I'm doing with the code, like you know, scrolling all over the place. It looks like 8 lots of the same image all over the place. It's quite strange. And then you can do a small change, push the code to it, and then suddenly get a black screen. I get nothing, and then you revert the code and I get a black screen again, and I'm like, oh my god, what is going on here? Is it my monitor? And I think it's the monitor. I think the monitor's like temperamental. It's like a 10% chance it's going to display anything if something's just a bit questionable somewhere. And all I'm doing is playing around with the RGB, yeah, and the timing for the RAM stuff here. So you'd kind of expect if the pixel data wasn't right, the monitor's display it no matter what. But I think the monitor's been kind of intelligent and going, the pixel data is not in synchronization with the H-Sync and V-Sync somewhere, something like that's happening. So anyway, I've gone back to basics and I've passed the input RGB straight through to the output RGB. So I'm not relying on the output of the RAM. And now we get something. If I show you this now, it was just a good test to go back to basics and make sure that the sync stuff is correct and that my monitor's not got an issue with the sync. Yeah, so as you can see, using the standard RGB frequency, you know, based, you know, it's going to be based on the 14 megahertz, isn't it? Effectively, that clock domain. It's probably less than that, but anyway, it's going to be in relation to the lower clock domain. We've got pixel data, and it's solid, yeah, and it's kind of as you'd expect. It's a quarter of the size of the screen, roughly, wrapped, yeah, you know, it's like half, if you like, you know, half the scan rate, half the, you know, everything's halved here, half the width, half the frequency, and trying to display the best it can. I'm not explaining that very well, but it's solid, it's stable, we can see all the colours there. I could move the mouse around, there you go, I can move the mouse. So at least we know the H and V side of things, the sync, is correct. The sync is not balked, so I now need to go back to looking at the different types of RAM. I think the obvious one, I'll show you on the schematics, there's the frame RAM, and the frame RAM feeds one of the line RAMs, one set of line RAMs, but then you've also got the other line RAM, which seems to take its, well, does take its signal straight from the, you know, interlaced frame, I think, at the relevant point in time. So I just need to confirm that by looking at the schematics, and I'm going to deal with that one line RAM that's on its own and just see if I can do the same thing here. If I can output from that chip at the relevant place. I might get it half interlaced. I might get like half a... I'm trying to think, that would only be on an interlace mode though, wouldn't it? And I think this is the complication, because I'm not using an interlaced display mode here. That chip is probably going to output nothing thinking about it, because there may be nothing to combine with it. I don't know. Anyway, I'll report back. Right, I've put it in interlaced, figuring that those RAMs now, both of them should get used, I think. Both the line RAMs. So I'm just rebooting that to make sure it is still in interlaced, because I tried to save it. It was quite difficult when the cursor was wrapping around and I couldn't really see exactly where I'm clicking. Yeah, there you go. So that is interlaced. So I'm now going to try and output from the line RAM that is not paired with the frame RAM. Let's just see. I think it's not paired with the frame RAM. Yeah, I'm sure it isn't. Let's just see, can I actually get something displayed that way? Oh wow, that kind of worked. Hang on, the colours look weird. I'm not quite sure why they look that way, but we've got something there, haven't we? Yeah, there could still be a timing thing there, thinking about this, because the colours just don't look right. What's this? It could be because of the wrap though, I don't know. You know, we've got this green sort of thing here. Yeah, the colours aren't right. I mean, let's just try and load a game or something. I don't know, load something with a bit of colour. Let's pull the bobble on, maybe. You never know, this might be the best I can actually get out of this display-wise, I don't know. Let's just see. Oh yeah, of course the resolution's changed now, hasn't it? It's not scannable, it's not interlaced. But you can see the bobble with strange colours there. Oh, hang on. There is a chance that my wiring is wrong on a couple of colour bits there in relation to that, and the wire might not be right that I added, because I did fit a wire because the PCB was not routed correctly in relation to one colour bit, I think, so on the delayed bit. Sorry, not on the delayed bit, on the combined bit. Yeah, I'm just thinking about this. I know what the shimmering is. The shimmering is because... Or is it? Hang on. Yeah, the shimmering is because we've got the same scan line fading to the next thing, if you see what I mean. So what I'm trying to explain here is, it's outputting a scan line, yeah, we've got that scan line data from the RAM. Then the RAM is disabled. Oh, hang on a minute, we're outputting a scan line from the RAM. So you're probably getting, certainly, yeah, you're getting a flicker, you're getting floating stuff going on, floating basically on one alternate scan line, if that makes sense. So if that was mixed with the output of the other scan line now, then it would be correct, I think. And this is half the problem I've got here. I'm having to deal with the RGB. The AGA Multifix didn't have to deal with the RGB. The RGB outputs, probably from the two different places, were just connected to the same thing. So like, well, when one's outputting, that's fine, and then the other one's outputting, the other one's outputting, the other one's outputting on the alternate scan lines as it goes down the screen. We haven't got that. We've got RGB input from Denise, we've got RGB from one line RAM, RGB from another line RAM, and then the output. And I've got to feed the output with the relevant thing. Do you see what I mean? So, in theory, if I adapted the test code I've just put in place there now to... on the alternate scan line to feed the other RGB in, maybe that would work. But you see, we've got a stable picture there. If I was to try the same now on the RAM that comes out of the frame buffer line RAM pathway, yeah, the delayed bit, I just get garbage. You get, like, you know, weird things all over the place, because the stuff with the clocks and the read enables and all that, the timing's wrong. For this chip, this set of chips here, we seem to be alright. Everything's alright, I think. I do think that that's looking good. I don't think there's an issue there. I think the shimmering is just the fact we're missing the scan line. You know, when I say missing a scan line every other scan line. And I'll show you what I'm doing here with my bodgy test code. So I've just got a block here that assigns the RC to C bus, the combined, whoever it is, line RAM, all of the 12 bits to the outputs 12 bits, and I'm doing it when the select, the read enable for that line RAM is set to 0, it's active low. So I've now qualified that with a condition, put a condition on it. I was going to put it in the place where this is set, but then I thought, well, let's just do it here, so it's got its own logic assigned to it, so that when the read enable is active for that chip, pass the video out. Yeah, I'm going to do the same thing if that works. I'm just going to test this now. So we've done a fit, everything's fine there, and then what I have to do is go to my Win10 box, delete my test folder, come back onto here. Go to the file browser. Yeah, it's a Linux based thing, this, and then copy to the share, avoid the log, skip the log, go back to my impact, which is already there, and I go program. It says the code's been changed, that's an impact, you want to reload it? Yes. So what I'd like to see when it finishes is a display still. Oh, we've got a display. Do you see the difference now? The difference now is it's even more flickery, but it's clearer. We've got rid of some of the shimmer, yeah, by qualifying, putting a condition, making it conditional when that chip outputs. So I definitely need to do the same thing now for the other chip, and then maybe one final condition somewhere for video that just passes straight through. But yeah, I feel like I'm making progress. We've still got this green thing here, which is bothering me, if I'm honest. And yeah, it's about to get a bit crazier, I think, because if I think about this now, if I go back to the code, yeah, I've got that many things open. Let me show you. It's like on a browser here. I've got Matsy's schematics open. I've got 3000 schematics open. I've got the CPLD pinouts there. I've got KiCad here to compare to the pins, to check the things, to see what's connected where. And then on the thing here, project here, we've obviously got the code and we've got the pin mappings, which I'm having to visit everything over and over and over here. Don't be under the illusion that this will take you 2 minutes to do, like I did. I'm like, I'll just do it in no time. Here we are a day later. I mean, alright, I only started the code yesterday, but you know what, and I only finished building the board the day before. It's amazing, really. In the space of 2 days we've got this far. It feels like that I can see the goal, I can see the end result, but well, we're still not there, are we? We all stand on the shoulder of giants, though. It's like I couldn't have done any of this without Matt's code. I couldn't have done any of it without the help of Liv2 and Mike T, and the inspiration from those guys and Stephen Leary. It's like I wouldn't be touching this development studio stuff here, ICE 14.7, if it wasn't for all the stuff Terrible Fire, Mr. Terrible Fire has done. So I think the next thing I need to do is uncomment some code I had earlier, put another end if line buffer. You can see I had code for this earlier on, I just think I had the logic wrong around. I was thinking it was like active 1 and it's not. So I just need to check, is it res 2, and this is where I have to go. So hunting off the schematics and I have to go, right, hang on a minute, let's think about this. So I've just looked at the read enable for these chips here, yeah, on his diagram, which is RE1, and these are the ones who use RE2, and I know those are the right ones because they've got Del. Oh, delayed. Yeah, delayed. The top one should be delayed. We've got that. Yeah, delayed. So it's RES2. Yeah. So let's try that. Let's just see if it changes anything. The video may get slightly worse in the fact that the odd scan line timing might be wrong. It should still mostly display, but just look a bit strange, I think. It's fair to say. But I do like the VM approach that comes with that install. You just go with the flow really with it. It does everything for you. See what that looks like, if anything. Right, so I'm really not sure what to make of that now. It's definitely outputting the two things. There's definitely a timing issue because we got like a ghosting thing going on, and obviously it's flickering pretty bad. Let's try a different resolution. Oh my god, I don't see what I'm doing with the cursor here. Let's just go into something that's hopefully a bit easier to do. I don't know, Devil's Temple maybe. It's like there's so many cursors, I'm like, which one's the real cursor? Oh god, I'm losing my mind doing this. colours look strange there, don't they? So yeah, you can see when we go to something that's not scan doubled, this is where I start to get quite confused, because I'm thinking, what is the issue there? I mean, it would make you think there's still something wrong with sync. I don't think so. I think it is about the timing on something somewhere. I don't know. I don't really know what to make of that. Let's just go back to interlace. Let's pretend we never saw that, because it's gonna stress me out no end. So thinking about this now, yeah, interlaced. We know the clock's right. It's clocking the pixel data through. Our mapping of the RGB to the relevant, the output. The logic of that would seem sound, that if it's in a read-enabled mode, you would want the video to pass through, because that's what would happen if we, didn't have the RGB lines going into the CPLD here. So what does that leave? Why is it wrapping? This is what I'm having a hard time trying to understand. I'm trying to understand the nature of, we've seen the wrapping in, and it's not getting better from adding the other line RAM in, and it wouldn't really if you think about it. So what would cause the wrapping? Oh my god, I'm getting somewhere. We've got it. I was thinking about the implications of, what about the RGB coming in? Why does that go into Amber? And it's because on the alternate lines, I think it's passing those through. Yeah? So, I mean, I would say that's kind of working. We've got a scanline effect, so that I am a little bit puzzled by. But, yeah, and it's frozen there. Yeah, this GBA 1000 has started playing up, and I think it's because it's warm. It's warm weather, and I think I need to downgrade to the 48 megahertz crystal, actually. I might have to go and get my crystal out in a minute, because it's cheesing me off this by, as it warms up, it starts to just become a bit glitchy. So consider this an update to the GBA 1000 video as well. But look, that's working. So I mean, that's interlaced. I don't know what's going to happen when we go into a normal game again. Probably it's not going to do anything, or it's going to go. It's going to be balked. Things we're not using the delayed at the moment, and that's going to be part of the problem. It's looking clearer. I think that this is. I don't know. I was going to say, is this where the delayed RAM is needed? I don't know. I'm going to take a photo of that, share that with the guys on Discord. Yeah, so that's that. Let's reboot it again, go back to the desktop, because I haven't got a keyboard connected, I can't get back out. I feel like I'm making some progress though, compared to yesterday, where I did spend a few hours and I was really tired last night trying to make sense of this and trying a few random things, and random things are never a good idea. As soon as I've gone back to logical thinking here, I've made some excellent progress. So yeah, it's not quite right in this mode, is it? Because it is, what's the word? Flickering a little bit. Let's just try going back to the resolution we had before. We'll go back to, at least I can see what I'm doing here now. The alignment's off, but it always is, it always adjusts this. This is one of the things that's par for the course with it, really. I just want to take it out of interlace and see what happens. Let's try it use, I'm not going to save it. Right, so that to me says that I'm not sure. It's this angle bit I don't get. If I was getting half and half, every other scan line, it would make sense to me. I can't quite understand why. Interlaced is displaying so much better than non-interlaced. Is it because it's all coming from that frame RAM and the line RAM associated with it, the delayed stuff? Is that what the issue is here? I mean, I would suggest so. I would suggest when we're in interlaced, half the screen is coming from the chip that's working. We've proven that everything's working with the timing with that. It's the frame RAM and the line RAM associated with it for the delay. That's where I think this issue is here. Right, so just re-enabling the delayed frame, we can see we've got a delay, ironically. So this now makes sense to me. If you look at the image here, it is capturing in the delayed line run, but it's offset, isn't it? It's offset here. Yeah? If this was over here, the image would now be absolutely perfect, de-interlaced. Yeah, I'm thinking maybe the clock. There's a signal, isn't there? I mentioned 14M something. Is that having an effect here? Let me try inverting it. It's not inverted, that clock, at the moment. I'm going to make it an inversion of the 14 megahertz. Yeah, I've just inverted the clock. I'm not sure 14 megahertz is supposed to go there, but it is marked CN underscore C at 14M. So, like, is that, what is that? This is where I might need to take the thing back into the room, put the real amber in, and scope that pin on the real amber to see what comes out of it. And obviously, if I was really intelligent, I'd get my logic analyzer, and I've got a few of them. Skip different types hooked up to see what's going on with that, because it may be a 40 megahertz conditional clock. In other words, it's 40 megahertz for a period of time, then it stops, and then it's 40 megahertz again, stops. 40 megahertz stops. There could be something like that going on. That might be a thing, and I can experiment with that. Yeah, if you've not already gathered by now, the way I like to work is experiment. And there's one thing that's easier to do than others, or a few things that are easier to do than others. Video and sound. That's actually better. A lot better. No, I don't think that is any better. I don't know. I'd have to compare an image side by side. Has that moved nearer? I mean, delaying it, you wouldn't expect it to move it nearer, so adding it, you think that'd be slightly further across. Is that the thing that's causing the issue, though? It could be the logic, thinking about this, on the signal that's used for the read-write enable, because it works on a flip-flop here, and I'm using like just the read enable coming across somewhere. I actually think I might need the inverse of the read enable, or I might need the write enable to help with that flip-flop, flipping at the right and flopping at the right time. So that might be the thing. I like to try and visualise in my mind's eye, though. That's the way I approach things. And when it comes to video and sound, you can kind of do that. You can use your ears to detect sound differences and issues, and you can use your eyes to detect visual things. Bear in mind, if you get no video as we were at the start, it's very, very, very hard. You have to go back to the simplest form of output, and that was where I just tried setting the screen to all white, and I got the white screen, and then I tried red, and I got a green screen, strangely enough. But the point is that's what you've got to do. You've got to look at the lowest level of trying to get some output, and then step up in complexity, and that's what we've done with this, really. Yeah, changing one of the signals that goes into one of those, the flip-flop there. I changed from a read enable S to write enable S. Maybe the logic needs flipping the other way around. Maybe it needs to be the inverse of that. I'm going to declare a variable, I think. Let's just switch the Amiga off for a minute, because I want it to be not warming up, and I've got that fan right next to my leg from the machine. It's freezing. Just things like the switch. I bypassed the switch for the moment, just hard coded it to a value. The bypass switch, that is. I've bypassed the bypass switch. So we can do that, but can we assign temp RE to a pin? I don't think we can. This is the thing that gets me about this. The comment characters, if you want to comment something out, it's not a dash, but it is in the code, it's not in the pins file. It's like, please be consistent. Don't change it between one file and another. It's just like the most annoying thing in the world. That might have been the original error now I think about it. In fact, it was. So it may have worked with a variable. Anyway, it doesn't really matter, does it? I need to switch the Amiga back on. Otherwise I'll get a JTAG error. Well, let's see what happens now. I might not give you an update for a while if this is not any better. Well, I'm quite confused. It's still flickery, and it is kind of offset, but what it isn't is how it was before. What it isn't, though, is completely misaligned. It is flickering. Why is it flickering? Yeah, we're adjusting the Yeah, it's not writing now at the right time, is it? So we've lost the data, if you see what I mean. That's why it's flickering again, and we haven't got anything overlaid. So clearly that's not made any difference at all. Flipping the logic round there. Well, it has made a difference. It's made the difference that you would expect it to do. Yeah, just testing the theory that the 14 megahertz clock that I'm looking at the moment, the one that goes into the flip-flop, is a conditional clock. So I've just put a condition on there, and it's stretched things out quite a bit. So I'm just going to try that a few different ways, the logic, and see if that makes any difference. But I mean, it stabilised the picture. It still looks flickery to me, if I'm honest. Certainly the lower half of the screen, it's bizarre. Maybe it's just like, yeah, it's an imaginary thing. It's flickering no matter what. Yeah, I figured his timing was different here, and I reduced one of the values there, counting pixels, I think 128 or cycles or something, and I reduced it to 32, and well, it's come a lot more in line. So that has given me a bit of a clue. Trying to get my head around. I don't really fully understand the chain of events here, and if you don't understand the chain of events of something like this, good luck trying to develop something like this. I mean, it's like, say, Matty at the end of the day is a god amongst men. He really is, because there's no way I could have worked my way through this code, I don't think. You know, created it from scratch. This project is entirely possible because of him. And that's the thing. I remember thinking that when I looked at the AGA Multifix. I'm like, someone could build Amber from this. And here I am, someone. Someone crazy. Ah. Ha 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 ha. It's that delay, isn't it? It's that delay. It's 2 pixels out now. I'm getting flashbacks from the AGA Multifix. It's a zigzag thing. If we change that to 0, I reckon it's going to be alright. But why? Why? That's the thing. I need to get my head around why. It's all very well changing things that you don't understand, but we haven't got 128 pixel offset now. I assume it's in pixels. I'll tell you what the variable is. It's field mem write reset, and there's one for PAL, one for NTSC, and well, there's 128 somethings that seem to be messing it up. It's amazing how my brain works. It's like, as soon as I saw that line of code and I was looking through the stuff to the reset, I'm like, that might be it. That might be it. Let's just try adjusting it. We've got nothing to lose trying it. So this is the thing. It's like trial and error. Suck it and see how you get on. You make an adjustment, and this is the thing I was talking about earlier about video. You make a small adjustment to some timing in some video signal. Well, things change and you can see it. And if you're in a position where I am here, then of course it's child's play to a degree, a bit of trial and error. This is like the Fisher-Price way of developing CPLD code. Right, program it up, see how that looks. I'm hoping spot on. It's not going to fix all my problems, this is not a panacea, but it might just give us interlaced. Now there is a difference, because, well, I think there is. I don't know, it's looking blurry still. I can't make my mind up about what's going on there. This is where your camera might actually help you, because you know what, you need high-speed shutter. Because what I need to do is see how are these scan lines aligned with each other. How many pixels out are they? Because that's going to be the clue here. Photograph it, and then have a look at my photo and see if it can make sense. Yeah, it's not far off. It's like it's one scan line or two, isn't it? I don't know. Is it 1 out? Maybe it needs to be 1. Not 0. I'll try it on 1. I probably won't work at all now. But I get no video. This is the other thing. You just get something on the fringe or something, and then it still doesn't look right to me. You see, we had 2 before. And what's this at the top here? This is another thing that's mysterious. Let's power cycle it. Yeah, and that's not right. We shouldn't be getting those rotating things there. You see, this stuff at the top here makes me think that we do need a delay. Right, so at the end of today's day of coding, we made some progress, some good progress. The code's a bit of a mess at the moment. I've got all sorts of garbage coming out on the screen. Anyway, I'm going to pull this out. So I'm using this extract here just to, you know, rock one way and the other, move it along a bit. Again, one way and the other, over that side a bit. Got to try and get it out carefully. There we go. I don't want to have to build another one or fix this one. Let's get that out of the way with this cable, the JTAG cable. And let's get the amber back in. I'm just going to scope one of the clock pins. It's going to be quite hard to get this in. I have to be very careful not to bend the pins. I think that's in. Hopefully I've not got a bent pin. Let's just try and power it on and see what happens. Right, so it's displaying okay. Yeah, I'm going to scope that connection there, which is field 0. So it's 1, 2, 3, 4. Fourth one down on the left side as we face like this way here. So I'm just going to clip the ground onto that massive screw there. Wish you could see what I was doing. Right, onto that pin, switch it on. Yeah, 188 megahertz. And it's solid. Hang on. Yeah, it's solid. It's me moving the probe around. 14.188. Which takes us to the end of part 3. So again, it's a shorter episode, same as part 1, not quite as long as part 2. But hopefully you found something interesting there, just seeing the progress we made really within the first few days of working on the code. You know, the first day I managed to build this, and then I started to get the development environment set up that night, and then overnight I was getting ready to test it. Day 2 was the start of this video really. So at the end of 2 days of coding, 3 days in total, we're kind of like almost there, but there were 3 or 4 at least issues outstanding yet to resolve that would lead to, you know, the final results, and I might be able to wrap that up in the next part. I don't know, it could be an hour long again. And I show you some screen captures of the actual code so you can see the code nice and clearly, and I talk through various things there and some of the problems and how I resolve the specific problems. So including the things you've seen in this video, I just, you know, quickly go back to them and show you the code and how I worked it out and how I fixed it. So again, a massive thanks to Mattias Heinrichs for creating the AGA Multifix. A huge thanks to Conrad Larson, because you know what, if I'd not built the GBA 1000, would I have gone down this road? I don't know. I may have not bothered because I only needed 1 amber. And again, Kavanos, if Kavanos had not sent me a 3000 board that was needed a lot of things doing to it, would I have done it? Same thing. So thanks to those 2 guys for providing those aforementioned boards. So please do like and share. If you'd like to support the channel, please do see the Ko-fi and Patreon links down below to keep videos like this going. I'll catch you in the next video.